Now it's recording. Hello, everyone.
Hello.
Today we are going to present our assignment, Solver Augmented LLM Reasoning for Collective Decision Making. My name is Ping Kwang.
I'm Andreas Wexell. So the task is that a number of friends want to meet up, and we want to find a suitable time that fits all of their calendars.
We have looked into related works. We find there are two studies quite relevant. One is using tabular structured data to evaluate LLM's reasoning. Another one is using still for scheduling, but it's more in a conversational manner. So ours is different in we still use natural language for prompting. Also, we compared with a logical solver in terms of the performance, and then we using their results compared as feedback and to hopefully improve the results.
So we have a number of experience parameters. We tweak how many friends there are and how busy they are. So with the LLM, we try between 2 and 10 friends, and with two kinds of calendars: busy calendars and causal calendars. And with the solver, we run the same data, but with hand created data for these 2 to 10 friends with their calendars. And then we try to let the LLM generate the data, and we run it through the solver to see if that improves over the LLM quality. But there we do with 2 to 10 friends, but only with the busy schedules, because it's quite time consuming to run this data.
This is the prompt we ask the LLM to convert into a logical model that the solver mini think can consume.
So for the LLM, our experiments, we run 5 experiments, and with busy schedules, it finds about a third of the available correct meeting opportunities, but it misses then 2/3. But it also incorrectly identifies slightly more opportunities than it finds. So more than half of the proposed opportunities from the LLM are actually invalid. For the less busy schedules, the cautious schedules, it finds more than a third of the correct meeting opportunities, but it hallucinates a little bit less, so that a third of the proposed meeting opportunities are actually invalid.
This is the code in MiniThink that corresponding to the schedule. We run this and 5 times, and we get the same result with quite reasonable response time.
We do this for both busy and casual schedules, and it finds the correct meeting slots 100% of the time, and it doesn't find any incorrect meeting slots. And so we changed the prompt for the LLM, so we add a system prompt in addition to the previous example user prompt. So in the system prompts, we tell the LLM that it is a minisync data generator and it can only answer with minisync data in a specific format. And well, it does seem to output data at least in the correct format, at least some of the time. So we take this and we create a full system where we use the same user prompts as we have for the LLM, but with this additional system prompt, and we run the generated data through the same minisync program as we just showed you. And we run 3 experiments with busy schedules only. It generally outputs data that does run in the solver. Of 27 runs, only 18% fail to run in the solver at all. It correctly identifies 1/3 of the available muting opportunities. So it's about the same as the LLM on its own. But some of the data is very, very wrong, and it sometimes makes the solver identify many available meeting slots. So overall, only about 5% of the identified meeting opportunities are correct. But it turns out that most of the hallucinations come from a very few set of the runs. So most of the runs are not this bad.
So to conclude the presentation, we think it is possible to augment LLM performance with a backend logic solver in a manner similar to RAG.
How to create such a system seems untrivial, and it seems to be a lot harder than we anticipated.
So that implies further research in this direction may be warranted. Thank you for your time.
Thank you.